the hinge theorem says just what we claimed. It's that in two triangles, or how about this? If two triangles have two pairs of congruent sides, again, they don't necessarily have to be isosceles triangles, but if we have two pairs of congruent sides, two pairs of sides that are each congruent, if we have this situation, then the triangle with the larger included angle has the larger third side. Okay. I'm drawing in, this is going to be very not to scale, but I'm going to try my best. If I have one triangle, or if I have two triangles, the triangle with the larger angle has the larger third side. Could be maybe a drawing for this. Here's a description of the hinge theorem. It's our comparison between two different triangles. And notice that this point that we have two pairs of congruent sides is extremely important. You can't use this hinge theorem or this idea of comparing triangles unless you know that's true. Unless you know that you have pairs of congruent sides, then you can't claim anything about the third side. Okay? And for example, and the reason would be this counterexample that I drew on the board earlier, where I have smaller angle yet larger third side, because I can change the length of the sides. Okay. Okay. This theorem's converse is also true, which is kind of neat. The converse of this hinge theorem is also true. Converse being the following. So if we have a similar setup, we have if two triangles have two pairs of congruent sides. So we have the same initial setup, but instead of knowing something about the larger angle, instead of knowing something about the angle ahead of time, we know something about the third side. If we start here, then the triangle with the longer third side has the larger included. It's a very similar idea, but we're kind of going in the reverse direction. So if I know something about the included angle, then I can talk about the relative size of the third side. If I know something about the length of the third side, then I can talk about the relative size of the third angle, or of that included angle, excuse me. Okay. Notice we only know something about, in this converse, you only can talk about the included angle. We don't know anything about the other two angles that are just that are floating around the triangle. All we know is something about the included angle, this between the two congruent sides, the two pairs of congruent sides. Okay. Again, as yesterday, notice this does not tell us anything about how to calculate the measures. It doesn't tell us that if you have two pairs of congruent sides and one angle is twice as big as the other, then the other side is twice as long. It says nothing about that. Doesn't say anything about how big or what or how to calculate the size. All it does is compare them. And all we can claim is that that one's bigger than the other, or one's smaller. The kind of a corollary to this, an idea that goes along with this, is what if you have two pairs of congruent sides, and then the included angle is the same? Then what can we conclude about the length of the third side? That they're congruent. Yeah, the corollary to this is say if the angles are the same, then one angle is not bigger than the other, so they must be the same size. Okay, and you could prove that theorem by saying that by using side angle side congruence of a triangle. Prove that corollary. Okay. So using these two ideas, tonight you're going to do a lot of comparing and then finding and setting up some inequalities to go along. Let's get some comparisons out of the way, and then we'll get you started on your homework, and you can see some of the. You'll get a chance to see some of the inequality equations you can write. So, for example, in between these two triangles, which side length has got to be bigger? DE, because we have pairs of congruent sides, and then the included angle F is larger than the included angle C, so DE. It's got to be the same bigger. In example B, which one is larger, 1 or 2? Neither one. They're the same measure. Okay. The opposite sides are congruent, then the included angles have to be congruent. And lastly, what's our larger side? TG. There we go. Okay. There'll be some question in your homework you'll get to that you'll have to use this idea to. You'll take this knowing which side is larger. Maybe I'll throw like a variable expression for how long these are. It's like to set up an inequality to find what x is, but it's not really anything terribly.